can't use normal CDF or inverse norm on these types of questions, okay? I'm going to tell you where are we coming from, okay? So when you are given, I'm going to highlight this part. When you are given limited information, you only have two values that are given, and you may at times be given the percentage of values located between them. And I'm going to switch colors for this one, or the associated z-scores. And I need to be clear here. I need to be very clear. You will have along the x-axis, there are always values, right? And they may differ, whatever we're talking about. You have your average, let's say the average number of hours someone sleeps, let's say it's 7, and the standard deviation is 1. So it'd be 7, 8, 9, 10, right? It'd be 6, 5, 4, okay? Things like that. But then we also have z-scores, guys. And we're going to talk a little bit more on that in the second part of today's lesson. The z-scores, we have 0, 1, 2, 3, -1, -2, -3. It tells us how many standard deviations above or below we are, okay? And so if you wouldn't mind, extend the lines so that you connect it with the associated z-score. Okay? But you have to remember, okay, that you could have a z-score. Oh, let's extend the mean to the 0, okay? You have to remember that you could talk about a z-score anywhere in between these values. It's weird to say, but you could have a z-score of 1.25 somewhere here, right? So these are just, in general, the ones we label, but we could have anything in between. Okay, remember that. So if you hear the words, or you see the numbers 68, 95, 99.7, those are very specific numbers. Those aren't just pulled out of nowhere. Okay? If you would like to think of it, 68%, we're talking about the middle 68. We're talking about the middle 95, and then we're talking about the middle 99.7. Right? So if you see the 68% mentioned, right? 68% of data points fall between the values. We know that this is referring to plus or minus 1 standard deviation. So there are two gaps that we're involving if it's 68%, or 2 z-scores. Write down 2 z-scores. Where is that coming from? 2 gaps, folks. If this is your mean and you go plus or minus 1 standard deviation, that's 68%, right? So look at this. 1, 2. We have 2 gaps that we're encompassing, or 2 z-scores, because this would be 1, 2, right? 2 z-scores are in between if we're talking about 68% of data. Okay. If we're talking 95. We're talking plus or minus 2 standard deviations. So 95, you want to be thinking 2 this way, 2 that way. So we're talking about this whole box right here. And how many gaps would that be? If you go from -2 to +2, count the number of gaps, and it is 4, right? There are 4 gaps in between that we're referring to, or 4 z-scores of difference. And 99.7, we're talking plus or minus 3 standard deviations. We're talking, if this is the mean, we're going 3 this way and 3 that way. So we're talking about this whole, I guess if we stick to the bell curve, we're talking about 6 gaps in between them. okay? So that's one thing I want you to be mindful of. And here are two formulas that I want you to include in your study sheets. I wish I had flipped them the other way, because this is the one you start with, okay? Start here every time, okay? Your first task is going to be, with the given information, to figure out the standard deviation, okay? Remember, this is standard deviation. This formula only makes sense when you have all of these pieces. So you have an upper and a lower value. You have a z-score of the upper value associated to that one, and a z-score of that lower value. So this is what we do. We subtract the values, we subtract the z-scores. That gives us a standard deviation. Once we have the standard deviation, we plug that in here to figure out our mean. Okay? We plug that in there to figure out our mean. So that's how we're going to do this type of question. Okay? So I'm going to skip page 52 for now. I'm going to ask you to go straight to 53. Okay? I'll say go to see page 53 in our notes. And we're going to go to that example. And I just need you to be prepared for something like this. And if you did the quiz and you left one blank, check if this one applies to that question. It's more towards the back of your quiz. Okay? So here we go. Raven and Dion are in the same applied class. Raven scored 62% with a z-score of negative 1.24. So she scored 62%, and that is the equivalent of a z-score of negative 1.24. Dion scored 83% and has a z-score of 2.49. Z-scores do not have units. Okay. Can we do a little bell curve real quick? This is your center. Go 1, 2, 3. This is your mean here. And 1, 2, 3. Try your best. Where would Raven be, if you just look at the z-score, where would Raven be, above or below the mean? Below, right? Because the z-score is negative. So this is a negative 1 z-score, this is negative 2, negative 3. This is 1, 2, 3. We're talking z-scores here. So we know that Raven is somewhere here. This is Raven. Having scored 62%, Raven is right there. Where is Dion? Dion has 83%, but more importantly, a z-score, a positive z-score of 2.49. 2.49 is going to be somewhere in here, correct? So we know the location on the curve based on their z-scores. Okay? So now, what this is asking is, what's the mean and the standard deviation for this class, given this piece of information here? This is the situation you're going to find yourself in when you know you have to use the formulas I just gave you. Okay? So I would always start with this. Start here. Start with a standard deviation. Standard deviation in this case would be upper minus lower, and I just call it z up minus z low. So what I mean by that is we're going to take 83%, we're going to subtract 62 from it. What's the z-score of the upper value? Look, 2.49, yes. Minus negative, the z-score of the 62% is negative 1.25, 24, sorry. You have to make sure you double negative, right? Because it's minus from the formula and the z-score happens to be negative, right? So you just grab your calculator. It's too early in the morning for me to be doing mental math. 21. I've never been good at mental math. I think I'm okay at it, but I'm very intimidated. I remember being in class and my teacher would do like a competition, right? It's like, yeah, right? I was like, I know the answer, but I'm freezing right now. So, but you can still be a math teacher and not do mental math, okay? Because you've got calculators. 2.49 minus negative 1.24. That's 3.73. When you divide these, you're going to get the standard deviation for the set. 21 divided by 3.73. The standard deviation is 5.63%. The standard deviation for this class is 5.63%. So that's part number one. Part number two is to find the mean. We use that other formula, which is x minus standard deviation times the z-score. And here you just have to be very careful. This one is non-negotiable, right? Once you get your answer, you put that in there. The problem is x and z. You're paying attention, it's early in the morning. You pick. If you want to use Dion's value and z-score, which is these two, then you plug those in here and find your mean. You're going to find the mean of the class. Okay? If you want to use Raven's information, meaning her score and her z-score, you can plug those in here. You are still going to get the same answer. So what I'm saying is make sure you don't mix up the value and the associated z-score. Okay? So we're going to go, I'm going to go with 83%. Okay? You can leave it as a percentage because everything is percentage. 5.63% times the z-score, which is 2.49. And you can plug that in one shot if you want to, because there's nothing dividing, so then you're fine. Okay? So the average is 68.98%. Or you could use, I'm going to highlight in a bit. Okay, I'm going to highlight to make sure you see the connection. X minus Z times standard deviation. If we use Raven's score, and then we go 5.63, which is the standard deviation, times her z-score is negative 1.24. Guess what these two negatives are ultimately going to turn into? Positive, right? If you multiply this negative times this, that's negative, times this, that is positive, right? So we better get the same answer, or else we're in trouble. And we get 68.98, okay? So it doesn't matter which information you pick. I'm just going to highlight here. If we go with Dion's score, it's got to make sure you keep them together. If we go with Raven's, You just can't mix them up, right? That's all I'm saying. But once you have your standard deviation, please start there. Then you figure out the mean and the standard deviation. Can you try this on page 54 real quick? Page 54. It's the same scenario. Give it a try. I'll give you the answers so you're not just walking blindly. The mean is 122.02. The standard deviation is 10.44 pounds. If you're done this, you go back to page 53, do the top question. It has a bit of a spin to it. In my opinion, it's easier, but it's kind of, you have to think about it a little bit. But first do this. Once you get that, go to page 53, do the top, and I will correct them both, okay? Maybe I'll give you the answers to that one. The mean on that one is 482 kilograms. The standard deviation is 17 kilograms. One time, guys. Are we okay with this one here? I think this one is basically copy-paste of the previous one. So I'm going to leave this one, but I give you the answer. Let's go to 53 and try that one, because some of you may not be so sure what to do there. This is where everything hinges on, okay? You ready for this? Generally, like it says generally, we're talking the majority of cases. And so it says that the mass of an Appaloosa horse is generally in the range of 431 to 533 kilograms. Assuming that data is normally distributed, determine the mean and the standard deviation in this case. I want to ask you to flip back one page. And I did put down the majority. If it says majority, we're talking 99.7. I will only do it with 99.7. The other two, 95 and 68, I will give you that number. I won't make you guess. But majority means 99.7, guys. What does that tell us about the range? It means we're going from here to here. And what are the z-scores then of the two values that they give us? On the low end, it's -3. And on the high end, it's +3. So this question actually gives you the z-scores for the values. Just it's not explicit about it. Okay, so let's go back. So we'll make an arrow here. Generally, we're talking 99.7%. Which, if you think about it, when is he going to stop with his bell curves, right? That's what you're thinking. Yeah. We're thinking 1, 2, 3. This is the low weight, which has a z-score of -3. And then we go 1, 2, 3 to the other end. That is the horse that weighs 533 kilograms. That has a z-score of +3. Okay, so this is the z, this is the z. So it essentially gave you the z-scores for each weight. So we can find our standard deviation now. Let's go over here. Standard deviation is upper minus lower actual weights. And then it's 3 minus -3, right? Z up minus Z low. And that is 102 kilograms, 3 minus negative 3 is actually 6. You end up with 17 kilograms as your standard deviation. If you find the mean, pick one of them. I will pick the low maybe. This is the formula, right? X minus standard deviation times the z-score. So X is 431, let's say, minus negative 3. Sorry, I'm mixing it up. It should be 17 in here and then negative 3. So let's fix that. I don't want to cause confusion here. And that is 482 kilograms. So your average weight of horses is this, and the standard deviation is that. Okay. So if you want more practice, 53 to 54, but you've done most of it already. I don't have a whole lot. And then quiz, plus the quiz has it, the one I gave you. You can find this type of scenario as well. I believe the one on the quiz gives you the z-scores. So